let's come on. So come on. So CTR mode. So CTR mode is like a good mode. Okay, so in CTR we are having, let's understand what is about CTR. So see, in CTR mode there is no feedback. One good thing is that there is no feedback, and we will maintain in bit counter. Okay,
can you explain what is meant by no feedback?
No feedback. So see, is this block depending on this block or not?
No.
Previously we are sending this, something is sending to here, so this is called as feed. If you are sending something here, this is called feedback. If you are not sending anything, then you are not supposed doing anything, so that's called like
okay, they are not interdependent.
Exactly. So that's it. So basically all blocks are independent of the previous ciphertext. Okay, let's come on. So basically we are having IV means initialized vector. Initially for the first counter we will initialize as a IV, for second counter IV plus 1, and so on. Nth counter we will initialize like IV plus n minus 1. Samjha? This is basic one point you need to remember. After initializing our bit, then see here again it is very simple. We are not using anything about small r bits. We are directly encrypting, we are directly XORing with our n bit plain text. Previously we have used r bit plain text, r is less than n, but here we are not using the r bit. Okay, we are directly using the n bit only. Happy? And next, that's it, simple. Like you will take this initializer vector, our counter, you will encrypt with this one, it will produce n bit, and you will directly XOR with, and again ciphertext. That's it. So let's see about security. So see, compared to OFB, I mean compared to whatever the OFB we have seen security issues, same is with CTR. So let's compare with CTR with other modes. Just like in OFB, you know, like OFB we discussed in the previous one, output feedback mode. So in OFB it generates the key stream. What do you mean by key stream? Key stream means small case. So here observe that carefully. Key stream is nothing but here this is K1, this is R bits are called K2 and K3 and so on. So using one big key, what is our big key? Initializer vector. Using that one big initialization vector key and capital K secret key, we are generating so many of streams, K1, K2, K3, K4 and so on, blah blah blah, like that. But in CTR, since CTR doesn't use the feedback, we can say that CTR creates the stream that is independent from the previous ciphertext blocks. Okay,
can you repeat it? I didn't understand.
You didn't understand? I will explain. So I am asking that whatever this is called key stream, K1, K2, K3. Now tell me, are these independent or not?
Yes.
Independent only, no? Because since ciphertext is not depending on here, so it can generate independently, it can generate independently, separately, happily. That's it. And one more similarity with ECB. ECB means our normal basic routine method. CTR creates the n-bit ciphertext block that is independent of each other. Those blocks just depend on value of the counter. Okay. That's it. And one more thing, this statement here, negative side is that just like ECB, CTR cannot be used for real-time processing. Why? Sir will not ask, but I am asking you, why CTR cannot be used for real-time processing? Because if you observe CTR is, so here as I was told, but like ECB, CTR creates n-bit ciphertext block that is independent of each other. Okay, that's it. So here negative side is that I am saying that CTR is not used for real-time processing, because see here you are using n bits of plain text, means you are using 64 bit of plain text. In real-time processing, data is slowly coming. So if you use like 8 bits, then it will be very easy, but you are using 64, means you have to wait till it will become this full one block size. So that's why like I'm saying it as a like not good. Okay, next, it's not used for real-time processing. So this is whole summary. So what I'm saying means here ECB is there, CCB is a block cipher, CBC is a block cipher, and again next 3 are stream ciphers. Okay, that's it. Okay, simple. Stream ciphers generally are more efficient for the real-time processing compared to block ciphers. Stream ciphers are more efficient for real-time processing because, as I told, because real-time is data is coming like this, slowly like this. So if you are able to easily finish this using stream cipher like 8 bits, like 1 byte is very cheap, like very easily available. So you can encrypt and directly send it. You don't need to wait till you will fill whole the block. Samjha? That's it. So in modern means currently what we are using means RC4 and A5 algorithms. Okay, let's talk about RC4. We will go through by one, line by line, what I have written the notes, so that you can understand slowly. This is not like previously I will just throw some words and you may be able to listen, but this is like slowly you need to understand. So listen this RC4 carefully. So first step, it is invented by something Ronald West for something used. It is used in SSS and DLSS. Not just remember that it is used in SSL, and SSL means like secure socket layer, and RTLS. Now RC4 is a byte oriented stream cipher. Byte oriented stream cipher means, see, I told that in stream cipher our major concern is about key genetic key. So byte oriented means our key size is a 8 bit. Samjha? Okay. So RC4 is generally based on a concept of a state. State is nothing but an array which is consisting of all different possible of bytes. So 1 byte means 8 bits. How many total number of possible present in 1 byte? 2 power 8 means 256. So basically state is a array of 256 which containing the values which is equals to their indexes. Okay, so what I'm saying means it is an array. For 0th index the value will be 0, for first index the value will be 1, and so on like that. This is like one step in initialization. We'll discuss about it clearly. So basically by doing magic we will select one of the block, means not block, one of this value randomly and use it as a key. Okay, as a key stream. I told previously RC4 is nothing but XORing with a key stream of 8 bit. So we will take randomly one and XOR with some what is the value of state. Okay, so next point is that mainly you have to remember that in key stream ciphers, whatever I am discussing A5 we are having only one secret key. It's common. One secret key is like secret key is a relationship between it's a very secret between like sender and receiver. So using this only secret key we are generating so many streams of keys. This is the main point you have to remember. Okay, our secret key is stored in the array. Let's say that array is named as a key. Samjha? Okay, the whole RC4 I am discussing here. This again struggles. Hello, Hare Krishna. So here first is about key initialization, state initialization. So in the key initialization, if you observe that this K is one array, okay, some different array. This don't compare with, see, listen here, don't talk others. this key, what I am saying, key is there, very important, will come in the question. This key is like our shared secret key array. Samjha? Shared secret key array. This key is like we are populating this array. We are just copying this array values into here. Suppose, see, this k is always, this k is a array name. This is always 256 bit. Key size is like key size is 256, not bit. Suppose our key is 8 bit. How will you transform into 256? Tell me. Simple. We will keep on repeating it till it will become 256. Okay. If our key, shared secret key is a 8 bit only, we will just directly copy as it is till k0 to k7, and after that we will repeat 888 concatenated. Okay, like that it will happen. So this is the state initialization, and it is value done by only once, and after that using this state we will permanent the keys and we will get one state. Okay, after that state we will do some circus. I will tell about these things very slowly. Listen. So here this is our encryption. So first this is initialization. What it is telling that initialize s of I with I value only. So that's why we are writing s of 0 as 0, s of 1 as 1, s of 255. Just you have to listen one more. No need to remember whole this thing. Sir will not ask anything. Sir will give you code only, and sir will ask to compute some values like ask in the quiz. Okay. That's it. And again key length. See, he understand this meaning. Key. So understand this value. Key is nothing. Key of 1 mod key length. So if key length is 8 bit and our key size is like this is always 255, 256. So you will this. What this mean is saying indirectly is that just concatenate 888 like that. It's saying. Suppose that's it. Simple. No, I'm not dragging here. So next here, this is our main. So permit the state. Permit the state means you are having state like 0, 1, 2, like a nice good looking values. Now you will do some magic here, and all the values will be like disabled, like like a scrambled. Okay, like and it will become like a different places. How you are doing means this using these equations. Okay, just feel that. Okay, initially we are keeping j as a 0 and we are iterating I equals 0 to 255 bus. Okay, samjha? So what we are calculating j as a j plus s of I plus k of I is equal to mod of 256, and then swap s of I and s of j. Okay, happy? So this is again this will be like continued till 255. After that you have got a one state of values of which is like a different like it's not in a ascending order as previous. After that here comes our magic. So what we are saying is out of this permutated initially permutated key state value we will select one value. So see, I'm saying that k is nothing but s of, let's think as a y. Okay, I'm saying k is s of y. So select randomly y value. At the beginning I have told this is like a magic, but I am showing these equations, so it's not a magic. Okay, just to feel comfortable, and I have told that it's magic. So basically this whole point is that according to equations, select one value, one index value, and fetch that value from that, and we are using that key as a plain text. And you again repeat this process till how many times? Till the times you are having plain text, you will do on the looping. Okay, so suppose let's say you in the real-time processing your plain text size is like 8 bits, like you want to encrypt using 8 bits. Okay, now I have received 7 bit. Till now I have received 7 bit. I will wait 1 more second so that I can get 8 bit. Once I will get 8 bit, I will do like key generation. I will select randomly one value from the state, and I will do simply XOR with the plain text, our plain text, to produce what? Ciphertext. And again now happy. Now I will not do anything. I will I will sleep for 8 seconds. After 8 seconds our new fresh stuff will become, means again 8 bit. Whenever I get 8 bit of plain text, again I do same processing. Take another random value of key, XOR it, you will get ciphertext. Like that I will send ciphertext. I will create the ciphertext. So this is all about RC4. Very simple. Just you need to understand the simple terms, so that whenever sir will give this code only to you, and the sir will ask please compute value of s of 2 after 2 iterations, means you have to perform this loop 2 times, like that, simple only. So next this is A5 stream cipher. Again we will go one by one what I have written, because it takes little bit time to understand. Okay, again A5 is like a stream cipher. It is used in our mobile communication system. In our mobile communication system, our plain text is there. No, they are calling like a one fancy name called frame. Each frame size is a 228 bit size. Samjha? I have told that A5 is a stream cipher. The whole basic fund of A5 is what? Generate equivalent of like 228. So here again the whole basic fund is plain text is just remember this, what that plain text is XORing with key to produce ciphertext. This is our encryption. So our whole story is about how to generate our key. Okay, samjha? Okay, so now our whole intention is that how can you will generate a 228 bit key. That is the whole thing. Here again in stream cipher I told previously there is one secret key between sender and receiver. That is secret key is like our 64 bit. Okay, now happily listen. So we will send this key generation one algorithm. It will generate only 1 bit. So we will do this time. We will call this key generation till 228 times, so that our buffer stream will be like 228. It will be absorbing blah 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 blah. Okay. Again, now in key generator, expanding this box, we are having 3 LFSR. LFSR means that linear feedback shift register. Linear feedback shift register means don't fear anything. It's like bacha means like, as it told, 19 bits. We are each bit is contained in one register. So we are having 19 boxes. Samjha? 19 boxes. And feedback means like at the beginning of this one we will have one connection feedback. That's it. Bus happy? Okay, nice. After that, see, in initialization, let's directly go to here so that you cannot understand and you will ask in the next class. Okay, so initially, since we are having 3 LFSR of each size, how much? 19, 22, 23. So we will initialize to all values as 0, 0, 0, 0, and after that we will iterate through whole session key, 64 session keys. Okay, so this is how the process is followed. At the beginning we will take this 0, and this 0 is XOR with these values coming from it. So 0 XOR with 0, 0. Okay, samjha? 0. Similarly 0, 0, 0. Now after that, understand this sentence. Clock all 3 LFSRs. Clock all 3. Clocking means, so see, understand that we will repeat this. Just understand one word. Everything will be self-explanatory in this. Clocking LFSR. Clocking LFSR means shifting each bit by 1. Okay, means 1, 2, 3, 4. Let's say I am having like this. Clock this register. I will say like that. So what will you say? Now you will become 1, 2, 3, and this value will be, you will get from the feedback. This is called clocking. Samjha? You understood? Clocking means just right shift that bus. Like that, similarly you will do for the 22-bit process. Okay. And one more thing is mainly here majority function. So this is all about self-explanatory. If you not understand, please DM me. Samjha? Please DM me. Direct message me. What is majority function? Majority function means whoever having the major value, those are called as majority functions. So majority function of 0, 1, 0, how much? Tell me. What is the measure here?
1.
What is the maximum number of times it's repeated?
Okay, 0.
Some happy, cool. What is so that's now what is majority of 110?
1.
What is majority of 11111?
1.
1. What is majority of 1011? 1. So bacha, simple only, no, like that. This is like, you understand, self-explanatory only. Some happy ending. Bye. That's it. See, the main basic here is about just read this thing stuff. So first we have taken this one, clock. So we have iterate over whole 64 bits and clock this 3 LFs according to the equation. And next we have taken 22-bit frame number. 22-bit frame number is like, it's a frame counter. What is frame? Frame is our plain text number. Okay, that's it. Using again this same similar, instead of 64 now you will take how many bits? 22 bits, and you will 22 times do this, repeat this step, and finally see, understand this step. Clock the whole generated based on majority function. Let's say I am saying these are the majority bits you need to investigate, look into deep. Now tell me which one you will clock. This is the questions asked by sir. Hare Krishna.
1.
This is 1, this is 1, this is 0. What is majority function? 1. So which clocks you will clock? Which LFSRs will you clock?
1.
This you will clock. And will you clock this one or not?
Yes.
Will you clock this one or not?
No.
But that's it. You will clock based on the majority function. But here in previously what you are doing, you are clocking all the LFSRs. That's it. Happy?